Square numbers are those numbers which is obtained when a number is multiplied by itself. Okay, for example, if 7 is multiplied by itself, then what do you get? You get 7 square, which is 49. Therefore, 7 square or 49 is called a square number. Okay, or a perfect square.
Ada kelas dulu ya jago.
Okay, 7 square is called a square number or a perfect square. That is 49 is called a square number or a perfect square. Why only integers? Why only positive integers? I have taken the number 7. I can take a negative number also. Let us say minus 5 into minus 5. What do you get? You get minus 5 square, which is nothing but plus 25. Because from the laws of indices, if you remember, from the laws of exponents, if you remember that there's a negative sign here and there's a then the even power. So what happens when I take this negative number out of the bracket and there's an even power? This negative number becomes plus 5 square, which is 25. Understood? So here your minus 5 square or 25 is called a square number. Or a perfect square. Similarly, if you have a fraction, like say 4 by 5. Now what is the square of 4 by 5? You multiply 4 by 5 with itself. You get 4 by 5 square, which can also be written as 16 by 25. Okay, 16 by 25. Here 4 by 5 square or 16 by 25 is called a square number or a perfect square. You can have negative fractions also. You can have negative fractions also. For example, minus 2 by 3. This. What is the square of minus 2 by 3? You multiply minus 2 by 3 by itself. What you get is minus 2 by 3 square. And again, applying the laws of exponents, I have a negative sign here. I have an even power here, so that when this negative power comes out of the bracket, because of this even power, it becomes a plus 2 by 3 square, which is 4 by 9. So here minus 2 by 3 square or 4 by 9 is called a square number. Or a perfect square. Okay, so 4 examples. You've got any questions till this part? Any doubts on the definition of square numbers?
No, sir.
Fine. Then I'll
No,
proceed.
sir.
Now, what you
No,
need to
sir.
remember is that you can remember these square numbers. Okay, you can remember these square numbers. One square is 4. One square is 1. Two square is 4. Three square is 9, and so on till 10 square. In fact, you should remember squares till 20. Okay, till 20, at least till 20, you must remember your squares. Okay, for example, what is the square of 14? You should remember it as 196. Okay, what is the square of 17? You should remember it as 289, because later on we are going to work with squares in a lot of other chapters also. We're going to work with squares in geometry also. Okay, so please remember your squares till at least 20. Okay, now what do you see? What you see is that in case of negative or positive integers, what you see is that the number 1 is a perfect square, is a square number. 4 is also a perfect square. 9 is also a perfect square. 16 is a perfect square or a square number, right? Now all these numbers are perfect squares. That means the numbers that are in between, that is these square numbers, say 2, 3, then you have your 9, then you have your 6, 7, 8, 10, 11, 12, 13, and so on. All these numbers are not perfect squares, are not square numbers. Okay, this means that all numbers, all integers are not perfect squares. Okay, because there are certain integers which are not square numbers. There are only certain integers like these. There are only certain integers like these, like your 1, 4, 9, 16, which are perfect squares.
अरे साबुन में ठंडा लग गया मुझे बेटे नौकरी हाँ
There are only certain integers that are perfect squares. Okay, not all integers are perfect squares. This is what it means. Now let us come to the very important properties of square numbers. The first property here is all natural numbers are not perfect squares. Obviously, as I showed you here, all natural numbers are not perfect square. If you see which numbers are not perfect square, 2 is not a perfect square, 3 is not a perfect square, 5 is not a perfect square. Therefore, all natural numbers are not perfect square. There are only certain natural numbers that are perfect square. What are those natural numbers? 1, 4, 9, 16, 25, 36, and so on. Okay, this is the first property, a very obvious property. Okay, and the next property is a perfect square can always be expressed as a product of pairs of equal prime factors. Very important property. Okay, this actually will form our basis of finding the square roots later on. Okay, how to find out the square root? We shall use this property to find out the square roots of numbers. Okay, let us take an example. Now, I want to check whether this number is a perfect square. I am going to use this property to check whether 1296 is a perfect square. So what I'm going to do is I'm going to prime factorize 640. I hope all of you know how to prime factorize. You have learned in your class 7.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
Yes, sir.
You prime factorize 1296. Now, once you're through with your prime factorization, okay, what you see is that these are, why are they called prime factor? Why is it called prime factorization? Because you see, whatever factors that are there here, all these factors are primes. Okay, all these factors are prime numbers. Okay, so that is why they are called, that is why it is, the process is called prime factorization, because we are breaking this 1296 into its constituent prime factors. All these prime factors we are breaking it into. Okay, now the property here states that a number can only be a square number if it can be expressed as a product of pairs of equal primes. Now what do you mean by pairs of equal primes? Now see, this is a pair of equal primes. This is a pair of equal primes. Two, okay, product of pairs of equal primes. Okay, this is a pair of equal prime. This is a pair of equal prime. This is also a pair, and this is also a pair. Okay, so therefore 1296 can be written as a product of pairs of equal primes. Product of pairs of equal prime means this is a pair of equal primes because both are 2. That is why they are equal primes. Okay, and a product of pairs of equal primes. So you have one pair. Next you have, so I have taken care of this pair. Now I'll see this pair, write this pair, 2 into 2. I'll write the next pair, and I'll write the next pair. So how many pairs are there? You see there are 4 pairs. Okay, there are 4 pairs, and in which these two are equal, these two are equal, these two are equal, and these two are equal. And 1296 is nothing but a product of pairs of equal primes. See, all these are multiplication signs. So that is why it is called, we say that pairs, product of pairs of equal primes. So if a number, any number can be expressed as product of pairs of equal primes, then it is a perfect square. So clearly, before writing this, just the one thing that I have not done in the note is, what you also must remember is that this can also be written as 2 into 2 can be written as 2 square. This can be written as 2 square. This can be written as 3 square. This can be written as 3 square. Okay. So that means this now can be written as, so what do you notice? I have expressed 1296 as a product of pairs of equal primes. Okay. And in the next step, what I have done is I have written it in terms of the power 2. I have written this product of pairs of equal primes in terms of power 2. Okay. This is a very important step, although it is not mentioned in this property. Okay. But we will be using this step. So you let me know if you have any problem with this step. Anyone having any problem with this step?
Sir.
Okay. So I assume no one has any
No,
problem.
sir.
Now see, remember
No, sir.
that I have
No,
expressed
sir.
this as a power 2. 1296 has been expressed as the power of 2. Okay, which means that I can write, therefore 1296 is a square number. Okay, that means I check that it can be expressed as a product of equal primes. Okay, and later I write it as a power 2. So once I write it as a power 2, I know that 1296 is a square number. This is the way you check whether a number is a perfect square or not, by prime factorization. Okay, let us take another example, 720. Prime factorize 720. Okay, so now you see what happens. You see that this is a pair of equal primes. This is a pair of equal primes. This is a pair of equal primes. But 5 is not paired. Okay, so 720 can be written as pairs of equal primes as 2. So this is your first pair. Next pair is again 2 into 2. Next pair is again a pair of 3. And the last one is 5. So what you see is that 2 has been paired, this has been paired, this has been paired. So that means I can write this as 2 square into 2 square into 3 square into 5. So what you see is that the power of 5 is not 2 here. The power of 5 is 1 here. That means I cannot write this number in this manner. Can I write the number in this manner as a power of 2? No, because the power of 5 is 1. So this means clearly 5 is an unpaired prime. Unpaired prime. Hence 720 is not a perfect square. (720) is not a perfect square. Fine. This is how you check whether a number is a perfect square or not. Any questions here from the second property?
No, sir. No, sir.
No, sir.
sir.
No, sir. Uh,
Next property. And again, an important property and very interesting property also. A number having 2, 3, this one, this property 3. A number having 2, 3, 7 or 8 in its units place cannot be a perfect square. This is the keyword, cannot be a perfect square. Okay. Any number which is having these digits, 2, either 2 or 3 or 7 or 8 in its units place cannot be a perfect square. Howsoever big the number is. Suppose I give you this number. A big number I give you. Can you say whether this number is a perfect square or not? It is not a perfect square because I see that 3 is in the units place. Directly I can say it is not a square number. Okay. Let us say I give you Can you say whether this number is a perfect square? Can anyone say
Yes,
whether
it is
this
a
number?
perfect square.
It is a perfect square.
It's a perfect.
It is a perfect
Yes,
square.
sir.
How can it be?
Yes, sir.
It has
So because there.
there's a units digit is 2, so it cannot be a
Yes, sir.
perfect square.
Oh. Hmm.
So similarly for 7 also, suppose I have a number like is this a perfect square? It cannot be a perfect square because I see
No, sir.
a 7 in the unit space. That's why it cannot be a perfect square. Similarly, if I have this number, is it a perfect square? It cannot be a perfect square because
Yes,
I see
sir.
an 8 in the unit space. Okay, so this is an important property and a very interesting property also, that any number having these digits 2, 3, 7 or 8 in the units place cannot be a perfect square. Cannot be. Okay, howsoever big the number is, even if you have a 100-digit number, big number, if you see a 3 in the last digit, cannot be a perfect square. Next property, property number 4. A number ending in odd number of zeros cannot be a perfect square. What do you mean by this? Let us consider this number, 5,000. Okay, the question is, is this a perfect square or not? I see how many zeros are there? 3 zeros. So this 5000 has odd number of zeros. Let's say has 3 zeros. Has 3, that means which is an odd number, zeros. Therefore 5000 cannot be a perfect square. Okay, let us take this number. This number. Now 16 is a perfect square. But I have how many zeros here? As 5, which is odd. So I have an odd number of zeros. Okay, therefore this number cannot be a perfect square. Okay, any questions here?
No, sir.
No, sir.
No, sir.
What about this
No,
number? Can
sir.
you tell me whether this is a
No,
perfect
sir.
square or not? Is this a perfect square? Can you tell me?
Yes, sir.
Why?
Yes, sir.
Why?
So there is 6 zeros.
There are 6 zeros. There are 6 zeros. Not only because of this, but also because there are 6 zeros, and also because 64 is a perfect square. Let me give you one more example. Let us take this number. Is this a perfect square?
No, sir.
Why? It has an even number of zeros. It has 6 zeros.
But
What is
85
it?
is not a perfect.
Because 85 is not a perfect square. Understood? So that is the main thing here that you must observe. See here, although 16 was a perfect square, we had an odd number of zeros here. We had 5 zeros here. So that is why it was not a perfect square. So both the conditions have to be satisfied together. That is, the number of zeros must be even. Okay, the number of zeros must be even, and also whatever number that you have, this number must also be a perfect square. That is why the entire number is a perfect square. Okay, but definitely for even for whatever number, if it has odd number of zeros, whether the other numbers form a perfect square or not, you can definitely say that it is not a perfect square. Okay, once you see an odd number of zeros, you can say it is not a perfect square. But if you see an even number of zeros, still it is not sure that the number is um, perfect square or not. Then you will have to check the other numbers. Okay, so I hope there are no questions from this. Next property. Squares of even natural numbers are even, and squares of odd natural numbers are odd. That means that, say, if I take a number, if what first an important observation. Let us take an even number, say 4. I square this. What do I get? 16. Right? Now, if you see, 4 is even, right? And 4 square, the square of 4, 4 square, which is 16, is also even. Okay, let us take an odd number. Let us say take 9, which is an odd number. I square 9, I get 81. So what I see here is that 9 is odd, and the square of 9, which is 81, is also odd. So what you see here is that if you take an even number and you square it, the resulting number will be even. If you take an odd number and you square it, the resulting number will be odd. So if I ask, what is the square of 997? 997. Will it be even or will it be odd?
Odd.
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 Because 997 itself is an odd number. So when I'm squaring it, it will be an odd number. Okay. So if I give you another big number, 4748, and I ask you whether the square of this number will be even or odd, clearly
Odd.
4748 is an
Odd.
even number.
Odd.
4748 is an even number. The square of this must be an even number. I heard someone saying odd. Why odd? I hope this is clear. You have understood this. Suppose I give you a
Yes,
big number.
sir.
Tell me what should be a square of this number, even or odd?
Even. The even.
It has to be even because you see that the number here,
Even.
this is an even. So the square of this must be an even number. Okay. So that is the rule. You square an odd number, you get an odd number. Okay. You square an even number, you get an even number. So it's something like saying you reap what you sow. Okay. You square an odd number, you get an odd number. You square an even number, you get an even number. Okay, so that is what this property is. Next property, and a very important property. Now, how do you determine the last digit of a number without actually squaring the number? How do you get the last digit of a number without actually squaring the number? Okay, that is the question here. Now, suppose if I have a number 799 square. I square this number 799, and my question is, what is the last digit of this number? Whatever number that you will get, what should be the last digit of this number, the units digit of this number? What you must see, what you see here is, or maybe if I take a simpler example, it will be easier. Suppose if I take 87 square, let us take 87 square, and I ask you what should be the last digit of the square number. So what do? You multiply 87 with 87. How do you multiply? Okay, 56, and you have a 60 here, a 0, 7, 8, 56, 8 into 8, 64, 64 plus 5 is 69. Right? This is how you multiply. This is how you find out the square of 87. Later on, I'll give you a better method, but this is how you find normally, right? What do you see? What is the last digit here? 9, right? So the last digit of this number must be 9. But how are we getting this? What you see here is that you are multiplying the last digit of these two. You are multiplying 7 with 7, and you are getting what? 49, which you are writing here. 9 you are writing here, and 4 you are carrying over. That means that this last digit, when you multiply, will give you your last digit here. That is what it means. Is this property clear? Or I'll take more examples, but is this clear that when I multiply 7 into 7, only then I am getting the last digit as 9, because 49 has the last digit. 7 into 7 is equal to 49, and the last digit here is 9. Now
Does this apply to all the numbers?
all the numbers, whether 2 digit or 3
Okay.
digit. Let us say I want to find out the last digit of this number. Let's say 128 square. Okay. So what do I do? What
Sir,
I do
4,
here is,
I think.
yes, I do. What I do here is I take the last digit of this number 8 and multiply it by itself. I get 64. So I take the last digit here. So that means whatever number you get, the last digit of this number will be 4. Let's take another example. Let us take 324 square. what should be the last digit of this number? You take the
6.
last, yes, because you take the last digit 4, you multiply by itself, you get 16. What is the last digit you see here? 6. So the
6.
last digit of this number has to be 6. Let us take a simple one this time. 121. What should be the last digit of this number?
1.
1.
Multiply 1 into 1, you get 1. So 1 has to be the last digit.
1.
Okay, let us take one more example and then I can proceed with the next property. Let us take hmm, let us take 176 square. Okay, so what should be the last digit? You take the last digit of this, multiply it with itself, you get 36. You're getting 6 as the last digit here. Okay, so I hope you have no doubts here. That is what this property talks about. Okay, even if you don't remember the property in sentences, but if you remember this is sufficient. Any questions here?
No,
No,
sir.
sir.
No, sir.
No, sir.
And I'll discuss the last property of the day. This is another technique by which you can find out whether a number is a perfect square or not, although not a very efficient technique. That much I can tell you. You cannot apply this technique everywhere. You can apply this technique maybe here and there, one or two places, but not. This is not a very important property. Property 8 is not a very important property, but you must know what it means. Suppose I want to check uh, whether 63 is a perfect square or not. Okay, so what I do is I keep subtracting consecutive odd numbers. What are the consecutive odd numbers? I have 1, 3, 5, 7, 9, 11, and so on. These are all odd numbers. So what I do is from 63, I keep subtracting. So first I subtract 1. So what do I get? 62. Now from this 62, I subtract the next consecutive odd number, which is 3.
59.
You get 59. And again, I have 5. So from 59, I subtract 5 to get um, 53, 54, right? And then next, I subtract 7 to get
47.
how much? 47. Yes, 47. Okay. Then from 47, I subtract the next number, 9,
38.
to get 30.
38.
And then from 38, I subtract the next odd number, 11, to get 27.
27.
And the next odd number from 27 will be your 13. So this is 1 and 14. Okay. And from 14, I subtract the next odd number, which is 15. So what do I get? I'm actually getting a negative number, right? I'm not getting a 0 here. Okay. Since I'm not getting a 0 here, at the end, that means, this means that 63 cannot be expressed as sum of odd successive odd numbers, consecutive odd numbers. It cannot be expressed. Therefore, we say that 63 is not a perfect square. Okay. Any problems with this? What I have done? I'll take further more examples, but I hope this example is clear. This means that since I have not obtained a 0 here, it means that 63 cannot be expressed as a sum of consecutive odd numbers. Okay, and since it cannot be expressed as a sum of consecutive odd numbers, it is not a perfect square. Okay, I'll take more examples in the next week. Okay.